Smart homes aren't science fiction anymore, are they? They're our reality. But as we're connecting everything from our lights to our locks to the internet, we're also kind of accidentally opening up a bunch of new back doors. So today, we're going to dive into a really fascinating new research paper that proposes a groundbreaking new way to fix this, using blockchain to make our smart homes truly, and I mean truly, secure.
And that leads to a pretty chilling question, right? Is your smart home watching you? Because every single one of those smart devices, whether it's your speaker or that new security camera, is a potential doorway into your home for someone you don't want. And traditional security? It often just can't keep up with the kinds of sophisticated attacks we're seeing today, leaving your privacy and your safety totally at risk. So here's what we're going to break down. First, we'll look at the hidden danger that's lurking in our smart homes. Then, we'll see why the old ways of doing security are failing. After that, we'll get into the exciting part, this brilliant new best-of-both-worlds solution. We'll walk through exactly how it works, step by step, and then we'll look at the hard data that proves it's fast, cheap, and unbelievably secure. Okay, let's get right into it. Because to really understand why this new solution is so cool, you first have to get a handle on the sheer scale and the nature of the problem with how our smart homes are set up right now. So get this, 27.1 billion. That is the number of Internet of Things, or IoT, devices that are projected to be online in 2025. This isn't some tiny niche issue. It's a global phenomenon. And with billions of these things all connected, the potential surface area for an attack is just absolutely massive. It makes having rock-solid security more critical than has ever been.
So what's the core vulnerability here? Well, most smart homes rely on one central gateway or hub to manage everything. And if an attacker can compromise that one single point, they can potentially take over your entire network. That's basically like giving a burglar the master key to every single door in your house.
And that one weakness opens the door to a whole nasty menu of attacks. Bad actors can intercept your commands, they can record your unlock signal and just replay it later, they can impersonate your devices, or even use one of your own devices against you from the inside. These are the real-world threats that standard security just really struggles to defend against.
So you might be asking, why haven't we solved this yet? Well, it turns out the two main ways we've tried to secure these things, they each come with their own pretty big fatal flaw.
And this slide just lays out the paradox perfectly. On one side, you have your traditional centralized systems. Yeah, they're fast and responsive, but like we just saw, they have that dangerous single point of failure. On the other side, you have systems that use only blockchain. They're incredibly secure, they're decentralized, but they're often way too slow for real-time stuff like turning on a light. So for years, we've been forced to choose between speed and security.
And this is exactly where the new research comes in. It proposes this incredible hybrid framework that brilliantly combines the strengths of both of those old approaches, creating a solution that is somehow both super secure and lightning fast.
And here it is, the big idea. You can see the system is split into two core parts that work together. On the one hand, you've got what they call the on-chain trust foundation. This uses a secure blockchain to act as the permanent, unchangeable source of truth for all the rules and devices. And then you have the off-chain intelligent layer, which is like the system's real-time brain, handling all the fast day-to-day operations. A great way to think about the blockchain layer is like an incorruptible digital notary. It stores the official, tamper-proof registry of all your devices and the fundamental rules for who can do what. This record can't be changed, it can't be forged, creating this unbreakable foundation of trust for the entire system.
The off-chain part, on the other hand, is like a hyper-efficient security guard. It's standing right at the gate, handling all the real-time requests. It doesn't need to run back to the slow notary's office for every single little thing. Instead, it makes smart, context-aware decisions in milliseconds, making sure everything is both secure and fast.
So, okay, that's the theory. But what does this actually look like when you use it? Let's walk through what happens when a user makes a simple request, like, say, turn on the living room lights. So here's the flow. First, your app on your phone sends the request to that fast off-chain coordinator. The coordinator then manages all the proof generation and does its quick security checks. It pings the blockchain just to make sure the permissions are valid, and once everything checks out, it submits the final transaction and gets a secure confirmation back. It's this constant, secure conversation between the fast guard and the trusted notary. Okay, but here's a crucial point: privacy. How does the system prove a request is authentic without just broadcasting your sensitive info all over the network? It uses this really clever cryptographic trick called a zero-knowledge proof. It's basically a way for your devices to prove they know the right secret key without ever actually showing the key itself. It's like proving you know a secret handshake without ever performing it where anyone can see.
But wait, there's more. Once the coordinator authenticates the request, it doesn't just stop there. It acts as an intelligent gatekeeper, running every single command through a 3-step security gauntlet to make sure it's not just authentic, but also appropriate for the situation.
So first up is cryptographic verification. Is the signature legit? Check. Second is behavioral analysis. Is this request pattern normal, or does it look sketchy, like someone trying to unlock the front door 100 times at 3 a.m.? And finally, a policy check. Does this request follow the rules you set, like, say, no one can use the smart oven after midnight? Only if a command passes all 3 of these checks does it actually get executed.
All right, so it's incredibly secure in theory. But is it actually practical? Can it keep up with a real house full of devices? The researchers ran some serious performance tests, and honestly, the results are pretty mind-blowing.
Get this, the system can do a full verification for a group of 500 different devices in just 190 milliseconds. That is less than 1/5 of a second. We're talking literally faster than the blink of an eye. This proves the system is more than capable of handling real-time smart home commands without any lag.
And what about the cost? Well, because that intelligent coordinator is doing most of the heavy lifting off-chain, the system drastically cuts down on the need for expensive blockchain transactions, and that results in a reduction of over 90% in what are called gas costs. Those are the little fees you pay to run things on the blockchain. This makes the whole thing dramatically cheaper to operate.
And this chart just says it all, doesn't it? Look at the cost just to set a single access rule. The proposed scheme is that tiny little bar on the left. It is almost 10 times cheaper than other systems it was tested against. This is what makes that super sophisticated blockchain-level security actually affordable for a normal home.
But here's the ultimate test, the real bottom line. Does it stop the bad guys? The security analysis confirms it. Man-in-the-middle attacks? Check. Replay attacks? Yup. Impersonation? Even insider threats? This multi-layered architecture is designed to shut them all down.
As the researchers Sony and Singh put it themselves, this isn't just a small improvement. By combining that unchangeable on-chain foundation with smart off-chain enforcement, they've really created a whole new class of security solution, one that's resilient, that can scale, and that can adapt to new threats.
At the end of the day, this hybrid model gives us a really powerful answer to the whole smart home security problem. But it also makes you wonder, right? If this architecture can so effectively secure our homes, what else could it protect? Think about it. Corporate data centers? Industrial control systems? What about entire smart cities? This blend of on-chain trust and off-chain intelligence might just be the blueprint for securing our entire connected future.